Okay, friends, let's look at a few more examples of some order of operations type stuff that we're going to be seeing in this class and beyond, and also show us how to do these with Google or some other kind of online calculator, which is super handy. It also has its limitations, as you'll see. So that'll be the next two videos, this one and the next one. So here's number, whatever number it is, 12 minus 11 over 5. So remember, it's a fraction bar. You don't see parentheses. So you might think to yourself, okay, there's no parentheses, there's no exponent, so I'm going to have to do division first. And then you might try to be like, well, how do I divide 5? What do I divide 5 into? That's kind of the wrong question to ask. The right question to ask is, oh, there's a fraction bar. Doesn't that imply that there are parentheses around the numerator and technically the denominator, although the denominator is just a single value of 5? And the answer is yes, there are, which means you have to knock the numerator down first. So this becomes 12 minus 11, which is 1/5. And if you want to go further, that's 0.2 if you want to make it a decimal. So the big thing, the big takeaway here is when you're evaluating something like this that's fractional, and this happens all the time in statistics types classes, you have to knock down the numerator and, if necessary, the denominator before doing that fraction bar division. Let's look at the next one, which is very similar. It's 12 inches minus 11 inches, there we go, all divided by 5 inches. Now, if you're looking at this one and going, it's the same as the previous one, I agree with you partially. It is very similar to the previous one because numerically it is the same. You got a 12, you got an 11, you got a 5. You got a fraction bar, which means there are unstated parentheses around there, but nonetheless very important. So then up here we did 12 minus 11 to get 1. Well, here we have 12 inches minus 11 inches. If you have 12 inches and take 11 of them away, you're left with 1 inch. So you end up with 1 inch over 5 inches. And here's where your work with dimensional analysis comes in. 1 over 5 is 0.2 or 1/5, whatever you feel like rating it as. What's inches divided by inches? What's inches divided by? What's 2 divided by 2? What's 4 divided by 4? What's 11 divided by 11? What's inches divided by inches? Same thing. It's 1. 1. They divide off just like they divided off? Yeah, just like they divided off in dimensional analysis. They divide off here because it's the same unit. It's exactly the same unit. That's what makes this kind of interesting, is that it's a ratio. It's kind of like when our son was very, very young, 3 feet tall. And I said, buddy, I'm twice as tall as you right now because I'm 6 feet tall. I didn't say I'm 2 feet times as tall as you. I said I'm twice as tall. Because if you compare 6 feet to 3 feet and divide them, the feet divide off and you're left with just 6 over 3, which is 2. Same thing that happens here. 1 inch over 5 inches is 0.2. Because this is 1/5 of this. Cool. Units take care of themselves like they always do. All right, let's do some more. Okay, so here's, again, a similar problem to the previous two. The big similarity, it's a fraction bar, implied parentheses around it. Another similarity, 12 inches minus 11 inches is 1 inch, again. Divided by 5. Is it 5 inches? Nope. It's just 5. That means that that inch stays there. So this is a perfectly acceptable answer. It's 1 inch divided by 5. Or, if you want to say it a different way, 1/5 of an inch. You can also do it that way. Or 2/10 of an inch. All of these are the same thing. The difference here is you're looking a measured value cut into pieces. So 1 inch divided into 5 equal pieces. Each piece ends up being 1/5 of an inch. This is different than the previous one. The previous one, the units canceled off because it was the ratio of 2 measured things. In this one, it's taking 1 measured thing and dividing it up into pieces. But mathematically, order of operations wise, it's all the same. Cool, let's do some more. Okay, this monstrosity. As crazy as this looks, this is actually something you do in stat classes. This is called the variance of 3 data points. Don't memorize that, of course. But it's nothing we can't handle. Nothing we can't handle. It's a fraction, which means there are implied parentheses around the top, and also implied parentheses around the bottom. So we've got to knock down the top and the bottom first before we do anything else. So let's just do it step by step. If I'm looking at the top, I notice that I see parentheses here, and here, and here. And those are within these parentheses. Nested parentheses, those are called. Well, that means we got to take care of those first, don't we? I think so. So that 5 minus 3 is going to be 2. So this right here is going to be 2 squared. I'm going to put the big fraction bar here. 2 squared. Plus 5 minus 5 is 0 squared. Plus 5 minus 1 is 4 squared. Now, you got to remember, we're also still working in the outside pink parentheses at this point. Still are. How about the bottom pink parentheses? Because there's something there to do now too. 3 minus 1 is 2. I'm not going to put pink parentheses around that anymore because it's now just down to a single number. There's no need to have to group that. It's going to be one thing. But the top we better do. Now we got exponents and we got addition. And we know exponents happen first. So I'm going to bring this over here. 2 squared is 4 plus 0 plus 16. And that's all over 2. And just to keep us cognizant of the fact that we're still dealing with that extended fraction, I'm going to put the top in parentheses. 4 plus 0, now it's just addition before we do the division. 4 plus 0 is 4 plus 16 is 20, so that's 20 divided by 2. And now we do the division, and that gives us 10. 10, absolutely. So that's a workout. That's a workout. And that is, like I said, something from statistics called the variance. It's a very important measure talking about how things deviate in a population or a sample. But the math's not too bad if you just keep track of those orders. You see a fraction bar, that implies parentheses, and then just work the order from there. Pretty straightforward. Let's do one more. It's a total bear. I'll give you a warning right now. It's a total bear, but it's very similar to this. Let's take a look. Okay, friends, I had to change rooms because I couldn't fit all of this on my chalkboard without writing really tinily. So I decided to do this instead. Okay, the numbers look familiar to the previous one. All I've done is I've added units in to each of the numbers in the numerator because this is often what you do in statistics. You analyze values, you crunch values of numbers. So in this one, we're going to do, well, first of all, before I say anything else, it's still a fraction, which means we still have those grouping symbols on the numerator and denominator. That's not going to change. Still exactly the same order of operations. It's just the numbers up top now have units. But don't worry, just deal with the units. That's totally fine. So let's knock down the numerator just like we did before. So the first thing we did was we dealt with those nested parentheses. So 5 feet minus 3 feet is 2 feet. So in the top, which I'm going to still put in parentheses, we have 2 feet, and those feet are squared. Don't forget the squared. We'll deal with him next. Plus 5 feet minus 5 feet is 0 feet. And that's still squared. Absolutely. And then 5 feet minus 1 foot is 4 feet. And that's also squared. I'm going to close those parentheses off because that's all the numerator. And then I'm going to divide. And that's 3 minus 1, which is 2 in the denominator. 2 down low. Okay, so it's getting a little bit nicer. And this is, in the previous problem, this is where we had 2 squared, 0 squared, and 4 squared. And we knocked that down to 4, 0, and 16. But these have units on them now. So if you take 2 feet and multiply it by 2 feet, you definitely start by getting 4. but you also multiplied feet times feet, which gives you square feet. Okay, friends, something hit me as I was watching hi Sean, work that last problem. Why is 2 feet times 2 feet 4 square feet? And I realized there's something we can add to make that more clear for you, I think. And here's what I think it is. What does 4 square feet look like? And I think what it looks like is, and I'm going to try to draw this to scale because I think I have a big enough chalkboard. If I take a foot measure, which is about this is about a foot long, and if I measure one and then another one, that's 2 feet. And then if I make a square, that's 2 feet on a side. That's also 2 feet up there. I'm going to erase that for a second. That square right there has 2 feet by 2 feet. What's the area in square feet? Well, what I just explained to you in the video was 2 feet times 2 feet is 4 square feet. But here's why. 2 feet, 2 feet, if we subdivide the square up like this square is 1 foot by 1 foot. That makes this a 1 square foot piece. This is also a 1 square foot piece. This is also a 1 square foot piece, and this is also a 1 square foot piece. So the base unit is now area. So when you multiply the feet times the feet, that's why it's square feet, because you're actually finding a second dimension. The context of that particular example we're looking at right now might not be super clear. Don't worry about that. I want to make sure the numbers make sense to you right now. So the reason that 2 feet times 2 feet excuse me, 2 feet times 2 feet ends up being 4 square feet is because the notion of squaring a number is called that for a very good reason, because you're actually making a square out of the quantity. Hopefully that makes sense. Sean, take it away. 4 square feet. And you can write it like that, or you can write it as SQFT if you want. It doesn't really matter. This is 0 square feet. And that one is 16 square feet. We're still going to put all that in parentheses because we're not done. If you're comparing this to the previous one, you're seeing a lot of similarities. Only difference is the units now. And we're going to divide that all by 2. And we got one last little thing to do, and I think I can fit it in there as long as I fit it in this little space right here. So if I have 4 square feet plus no more square feet, that's still 4 square feet, plus 16 more square feet, that gives me 20 total square feet. All divided by 2. And this next number is going to look familiar too. 20 square feet divided into 2 equal pieces is 10 square feet each. So it's 10 square feet. 10 square feet. And there you go. It's just like the previous one. What makes it tricky or somewhat weird is the fact that we have these units that we have to deal with. But they're not that bad. You just got to keep track of them. It's all about keeping track of the units and then applying the correct order. So now you can see this like the next logical step in the progression of our course. We've now added dimensional analysis, unit arithmetic. No graphs here, because this is mostly the numerical stuff. But it's still the same kind of number sense, just building on it. Cool. Let's see how to do these in Google.